Okay, I will explain here how to use my repository of Tensorflow serving with the Fashin MNIST Dataset. The first thing that we need to do is to install Docker. You can get Docker from this site. The specific version of Docker that I'm using is the Docker Edge. So you click on download Docker for Windows, then goes to the Docker Hub and download the Edge version of Docker. So we need this because we need to enable some features, some advanced features of Docker. So you click here and download Docker. Next, you need to install Docker. When Docker is installed, ensure that you can run Docker. After that, you right click on the Docker symbol, click on settings, and there is a special feature to enable here. It's called experimental. You put it to true. For example, I will put it false, and apply and restart. I will leave it to true. Next, when you restart Docker, the next step to do is to use TensorFlow serving. So with my repository, there are only basically two files, the train and the test server. That files we will use to test Docker on Fashin MNIST Dataset. But by now, the first thing is to install TensorFlow serving, do these steps on Windows to get this return output. So first thing, you need to do a Docker pull of TensorFlow serving. So let's do it. Docker pull. Note that I am on the downloads folder. I get my repository downloaded on the download folder, as you see here. But right now I'm downloading only the Docker image. Okay, here is the Docker image that I download. Next is to clone the repository. You need to clone the repository on your specific file or folder. Mine is downloads. You do that, obviously there is an error because I have the TensorFlow serving downloaded from GitHub. The next thing, what we want to do is to test the server. So for testing the server, I run this command, but with some specific parameters. Let's see here. This is the command. All is explained on my GitHub repository. So basically, we will run a Docker container at the specific port for the REST app API mounted on the current directory, serving, TensorFlow serving, servables, TensorFlow test data, saved model half plus 2 CPU version. This is on serving, TensorFlow serving, I think it's servables, TensorFlow, test data, and here saved model half plus 2 CPU. There is the model, and inside the model there is an asset folder and variable folder, and the important file here is the saved model.pb. So we will specify here the binding for the TensorFlow model. This is how the model will be called. Next we specify the model name and which type of container we are serving. If everything goes well, you will get this output. When you get this output, you can press Ctrl+C and see if the container is up and running. Docker container list. Here is the container running. It's the TensorFlow server at this port, the 8501. So for testing the TensorFlow container, if you put this command on Windows, obviously it will not work because Windows do not have curl. So you need to do this next thing. You need to download curl for Windows from this site. Connection problems. Okay. Okay, you go to download curl for Windows, the 64-bit version. So you download curl this way. Uncompress curl from on a directory that is not privileged or do not have the requirements for administrator. So let's extract here and change the number, the name I mean, for curl. Next thing is to cut and paste. I paste it on the program files folder. See, program files. Here I pasted curl. And the next thing to do is to update the path on the environmental variables. So next we need environment. Go to environmental variables, next to path, and I get curl here, the bin path to the executable enable here. Press OK, and if you go to the command window and press curl, you should see something like that. That means a curl is enabled. Now for testing the server with the model that is on the server, we need to make a little modification here because on Windows this will not work. We need double quotes here and here. That's why I'm doing here. And next we press enter and we get a response from the server. So that's the first part for testing that we are up and running TensorFlow serving. Now that we test the model and all goes well, the next thing is to stop the server because we are trying to run another model at the same port. So you can do it on other ports. So for stop the server, we need the container ID and then stop. And that's all. So for testing the Fashin MNIST dataset, I made two files, one for creating the model and the other one that calls or make a request to test the model. So let's see, where is okay, let's delete card. You could also install wget. It's an optional thing to do. It's not necessary for this demo, but you can download curl. Download wget. So you need to repeat the same steps that I did on curl. The other thing that you need to do here is download the binaries. Download this binary and these binaries that are the dependencies of wget. So unzip both on the same folder, let's call it wget, and move it to the program files folder. Finally, add it to the path folder and repeat the same step. Open a command prompt and type wget. You will see an output. So if you want wget and curl that are common tools on Windows, then you can do it in that way. And then you can enable it. For example, I have wget installed on Windows. It's pretty handy. Now, returning back to the TensorFlow serving part. Okay, and for training our model, first, obviously, if you have a virtual environment, you have to be inside the virtual environment. Next, I have a file for making a model training and testing. Train and save model is called. Just press enter and it will run. So here we are trying to download the MNIST dataset. We make a simple convolutional neural network just for testing. I only need the model to test the server. Next thing to do is to train the model for 5 epochs, and finally save the model to a temporary file. You can move the model to another folder, but this example have made it to store it on a temporary file that is stored on that location that I put here. Here is the model. This is the save model. Here's the assets. It's not inside the variables. Obviously, we need something on the variables. And if you want to view the model, you can use Netron or TensorFlow. But let's do it with Netron. It's pretty neat. So, okay, the side of Netron is that one. We will load the save model. Netron. This one, sorry. Next, we will open the model. Here I loaded previously. And with Netron, it's a pretty useful tool. You can view the model of your convolutional neural network. Even also you can view all NX models and so on. So we ensure here that our model is a valid model, a valid TensorFlow model. That's why I open this window. And the next thing to do is, when I train the neural network, the other thing is to run the Docker container of the Fashin model. Here we will run the Fashin model container. Here. We will be sourcing the model from the temp folder. Note that I did not put the version of the model, and also I have to put a name of the model that we will be referring to that model on the TensorFlow, on the Python file. Later I will explain what is inside of the trainer and what's inside on the server tester. And the model name is the Fashin. Obviously, we're using Tensorflow serving. So the next thing is to run the container, and if everything goes well, we will be up and running our server model. I mean, okay, the server started successfully, and we will test the server. If we test the server, what it's doing is loading the test images and putting the test image on the server and returning only the ground truth value. I will not return the JSON. The JSON is inside the file. So it will take a little bit because it will load the MNIST dataset. And you got here, and the test image, everything is, this is the shape of the test image and the labels. Only the test image. This is a ground truth of a single image. So the ground truth is ankle boot class 9, and the prediction was ankle boot class 9. And if you test on multiple requests, you got ankle boot class 9, prediction is ankle boot class 9. The second prediction ground truth is okay, and the third prediction ground truth is okay. So this was the test of the server, or the TensorFlow server. Now I will try to explain in a brief the files of the repository. Okay, let's open Sublime for that. Okay, let's go first for the trained and saved model. First, we load the necessary libraries. Print the TensorFlow version. I'm using TensorFlow 0.3.0. Next, I load the MNIST dataset, the training labels and the test labels, also the images. I normalize the train and the test image, get the shape. Obviously, the MNIST dataset has 10 class labels. So here are the names corresponding to the class names, to the class labels. And print the shape of the training image and the test images. Next, we will make a convolutional neural network. It's pretty simple, just a convolutional layer, flatten it and make it dense with 10 outputs by the softmax function. Make a model summary, compile the model, and we test model that will give us the accuracy at the end, and we will print it. Finally, this part of code, the only thing that is doing is saving the model. So we are saving the model to a temporary directory that was explained before, and I print all the files inside the export path. That's the part of the training that you saw previously. And for testing the server, I use the necessary libraries. Obviously, we need JSON, request, NumPy, TensorFlow. Here, I'm loading the test images. I only need the test image to test the container, the server. Obviously, again, I load the labels, print the shape just for testing, and here is the part. I made a single request. I made the request here. First dump the data at this of the image in that way, and finally put that headers because we need to send a JSON file at the end. I made a request to the MNIST dataset. Did you remember that I made it by name MNIST? Well, we need to put it here. And also we need to specify the IP, the port, but the most important part is this one. What's the name of the output? The output is predict. So at the end, we get the predictions and print those predictions on the output window. And the same is repeated for the multiple requests, but in that case I'm doing a request for a specific model. If you see here, I put Fashin version 1.predict, so it's pretty handy because if we need to test another model, just train another model, let's say 2, and change it here, and we can switch between model A and model B to do a A/B test. So that completes the explanation of the code example of training a model and serving with TensorFlow serving. Hope you understood what I was doing. And if you got any question, just write me on my GitHub below. On the repository are all my links, are my contact links that you can make me an email, contact me on LinkedIn or any social media network. Thanks.